analysis. And her presentation is open for discussion.
On one of your tables, you had log of A. What does that mean?
So So the A is the absorption at zero frequency, but because it's too small to measure, so I use logarithm method. So.
More questions?
Could you provide more analysis? Like you were putting these different alignment, different positions, right? And so you're saying, okay, electronic structure is definitely affected, but this is very trivial result. You can say it without doing any calculations, right?
Yeah.
So you can give a little bit more physical or chemical explanation, like in which case, which one is why this or that, right?
So for sure we can see there's difference on like the oxygen definitely affect the density of state.
Like when you compare, for example, substitution of oxygen versus just kind of attachment of O2 molecule, his absorption of O2 molecule, right? In both cases, your gap is decreasing, and right. But is it the same nature? Any difference in electronic structure between these two cases, or it's exactly the same behavior? In other words, can you differentiate these two cases just looking on your electronic structure somehow?
Not really. I don't think so.
But do you expect it should be different, or something should be different?
No, I was hoping to have more time to look at other ones, but I only managed to get this much information result.
But did you take a look on the orbitals localization? Maybe this could give you some ideas.
So
right?
for the HOMO and LUMO, it does not change a lot except for this one. It has localized orbitals on the oxygen.
In which case, when you substitute or when?
No, the one that I put on top, just the normal.
So when it's phys-adsorbed, then you have very strongly localized orbitals. And these orbitals introduce this closing or this sites inside the gap, right? And the other cases, when it's substituted, it's more delocalized over the surface, although the gap is still changing.
Yeah.
Okay, so you have a different nature of this electronic states. Okay.
Thank you.
Dr. Khan?
So what happened? So for the undoped system, it's a semiconductor, right? With a finite band gap, right? So that's true.
I would guess so.
How large is the band gap for undoped system? What is the gap?
Yeah?
Yes,
The
approximately.
energy gap. The energy gap. Yeah, it seems to have a finite band gap.
You mean this gap?
No, here. From here to there.
In the pristine case.
So it's a semiconductor, right?
But
Yeah. Yeah. So
what is the size of the
semiconductor,
gap?
I did not come.
Approximately,
You
like
can look on your phone, right?
0.1 electron volt, 1 electron volt, 10 electron volt.
Two?
Okay,
Yeah.
Around 2 electron volts.
So about 2 electron volts.
Yeah.
So what happened when you put some species on top of it?
It is
So the system is still a semiconductor, or it become a metal?
It's a semiconductor, but I believe it's a semiconductor. It does increase.
what does happen to the gap?
It decreases.
But it
would
still
it-
exists, right? It's not completely going to zero.
Yeah.
Okay,
So it's still a semiconductor.
But then, whether it's a semiconductor or not, it also depends on the position of the family level, right?
Okay.
but you are telling that it is not going to, it doesn't transfer to the metal.
No.
It is still a semiconductor.
Yeah.
At least what you found. Okay, but thank Whitney once again.